All right, we're live. It's the 30th of October, 2024. This is Plutus PBL Live Coding from Gimbalabs and Friends. Today, we're going to keep working on some validators, just like we were working on last week. So in last week's session, we covered the first three learning targets of this Validators Essential module. And let's look at it in the actual course view. So at ondamio.io/courses, you can access this course by navigating to Plutus PBL 2024. And we are looking at module 205. Now, last week we got started and we covered the first three learning targets. We looked at a validator that succeeds after a specified timestamp. We looked at how to build transactions to deploy that validator on chain and to use it in some transactions. And then I introduced this idea of purpose. And so we saw a spending validator with the spending purpose expressed. And right before we went live, Faizan and I were talking about this. And he asked, what about minting validators, for example? We're not going to cover minting directly in these examples because the goal is to show you a couple of concepts that are going to appear in many different spending contexts. And by focusing on spending first, we get to really think about each of these key ideas. Then, if you want to go deeper with something like the like minting validators, or another thing I'm trying to inspire you to be interested in is testing transactions. All of that's covered in Aiken PBL. And this course is not quite live yet, but we're just about ready to publish it. We tested it in person back in September, and now we're refining the content, but you can see what's going to be covered there. So really excited to get this out there, and you can bet that we're going to be using more of our live coding time to look at this content as it goes live. But for today, we're still in the Plutus PBL course, introducing these concepts, and this gives us a chance to build up a lot of background knowledge around what a validator does and how you use it in transaction building. So that's what we're going to jump into. And I think we can move pretty quickly through these next four examples because they're all similar to what we've already done. We're going to repeat the steps that we looked at last week of compiling a validator. We're going to repeat the steps of deploying the reference script, using it in a transaction, and then we're going to add little features as we go. And I'll point out some of the important details as we work through this. In order to follow along with the code, right here in Gimbalabs GitHub, you can see a couple of examples. I already dropped the link to Aiken examples into the chat. I'll do that again just in case anybody just arrived. And we're also going to use the transaction examples. You'll remember that we started to use this last week when we tested the validator and we looked at the spending purpose specifically. We're also using the deploy reference script in order to deploy our validators on chain. And I'm going to show all of those steps again, but in case you want to follow along, here's the link to that. Over in my Visual Studio Code editor, I have both of these repos open. So here's the PPBL 2024 transaction examples, and here's the Aiken examples. And we'll be following along, navigating through these files. I also have a node running. My node is synced to Cardano pre-prod. If you're running a node locally, you'll be able to do everything that I'm showing you today. But if you want to run all of this on Demeter Run, the documentation is in the course to do that as well. If you get stuck on any of that, just be sure to ask questions in the Gimbalabs Discord or stop by a live coding session and we can troubleshoot that. But that's why you're going to see me running these transactions locally. Of course, it would work exactly the same way on Demeter Run if you have Cardano node access turned on. Great. So let's look at a couple of examples. Last week, we left off right here. with a validator where we introduced spending purpose, but we had underscores in front of datum, redeemer, and input. And what those underscores mean is that we can safely ignore these arguments of the spending validator. They still exist, right? The transaction using this validator is going to be able to reference datum, redeemer, and it's going to, of course, have inputs. We're just not using those in our validation code. And just to show you one consequence of this, let's jump back to a terminal window where I'm in this directory, right? No, in the wrong one. Let's go to, oh, and those are the scripts. Hold on. This is my Aiken directory. Yeah, that's the right one. Okay, so this is the introduce purpose project that we're looking at right here, introduce purpose. And if I remove these underscores, I want to show you what happens. I'll save this file. So now datum and redeemer are consequential to the spend. It's paying attention to those values. And watch what happens if I run Aiken check now. I get a whole bunch of, well, 2 warnings that tell me these are unused variables, right? That's really helpful. It says no big deal. It's still going to work. These are not errors, but you can decide whether you prefer to see these warnings or not. In order to suppress those warnings, I put the underscores back on here. I'm going to run Aiken check again. And this time it doesn't show me the warnings. So that's just a little review. We looked at how this works last week, and you can review the video. Let's jump into this first example. It's called Introduce Traces, and this is the example for lesson 205.4. This time you can see that datum and redeemer have the underscores removed, and we are explicitly defining the types of each. It's an option int, and we're going to see the consequences of these types in just a minute. We use these, right? The reason we don't get a type checking error when we run Aiken check, I'll show you right now. So let's navigate into SLT 2054 in the Aiken repo. Introduce traces. Here's the directory. We got our validators. This is the file I'm looking for, aiken.toml. If I'm in a directory with this .toml file, I will be able to run Aiken check. And as you can see, there's no warnings here. There's no warnings because these variables are used. Where are they used? Well, down here. And this example introduces our first validator that has 2 conditions that must be true. In the previous example, introduce purpose, we were only validating on a single condition, must start after, and we used our helper function, which returns true or false. In this example, we use the double ampersand, right, the and sign, to say that both this condition, whoops, and this condition must both be true. Nothing's changed about must start after. We still specify a lock until time, just like before. We pass it the validity range from our transaction. We pass it whatever lock until value we specify. And then the must start after function is exactly the same as in the prior examples. What's new is that this validator will only validate if datum is equal to redeemer as well. This integer specified in the datum must be equal to this integer specified in the redeemer. So that's what we're going to look at right now. A, how do I build a transaction that accounts for both of these And B, if my transaction fails, how can I figure out why it's failing? Is it failing because datum is not equal to redeemer? Or is it failing because I'm outside of the validity range in this validator? We're going to look at both of those ideas at the same time right now. Yeah, Steve.
I know this is a stupid question. I just want to verify how stupid. The statement "let lock until" that's a time. That's a reference to time.
Exactly. This is a timestamp. Let's take a look at that right now. And in the lesson, there's a link provided. So let me show you the draft of the current lesson because we can work through this to make sure I'm covering everything. And I'll publish it right now. I'm going to publish this even though it's incomplete. So you can follow along right here. And in the lesson, did I include the link to Epoch Converter, or is it in the previous one? Yeah, it's in a previous lesson where we first introduced this. Maybe just the first one. Okay, but it's this link right here, and then the step-by-step instructions that we covered last week. This is the tool we used. Okay, so here's the current number of seconds since midnight on January 1st, 1970. And when we talk about POSIX time, all we're doing is we're adding 3 zeros to this number because they're milliseconds that we want to account for. And so I actually need to reference this site right now in order to keep going. Let's build a version of this validator that's going to allow me to unlock tokens 20 minutes from now. So 15:09, how's that? And we want the milliseconds timestamp, so this one. So I'm going to copy that new time, paste it right here. A week has passed since we last updated this code. All right, so this is what I'm going to be able to compile, and now we have the latest current time. Yeah, Colin, what do you think?
Oh, no, that was good. I was just gonna, and this is another one of those really basic on the backside things. In this, you're gonna call introduce trace with datum redeemer. That creates an object. When you reference spend, you're gonna try spend, and then it's gonna do some stuff. If spend is that at the bottom, it says data equal redeemer. If that fails, how does it get to else? Um,
Oh,
like else
great.
is a
Okay,
fail.
great question. That's actually a really important question. I'm going to show you what happens when this fails in just a minute. But before I show you that, let's talk about
Oh, okay.
else for just a minute. All right.
Yeah.
In this case, else is distinguished from spend. You see how they're on the same level.
Right.
And what this means is that this validator can only work for spending transactions. If you tried to use this validator for a minting transaction, that's when it would hit the else endpoint.
Okay. Okay.
Okay. And if I tried to mint, what would it do? It would fail. And every other purpose as well. Let's look at the Aiken docs for just a minute because I wanted to point you to these anyway. So here's the Aiken homepage. And at the top of the page is a link to the standard library. Of course, you can also read the documentation. But in the standard library, there's a transaction section, and this is really worth reading through the whole thing. We looked for a moment at the transaction constructor last week, and you can see why we are able to talk about the validity range. Let me jump back to the code, right? The validity range right here, because that's one of the fields in the transaction as it's defined right here. But any of these other fields can also be used in validation. For example, You could build a validator that only validates if the user pays some higher fee. I don't know why you would want to do that, but you could. Okay. We're only focused on validity range, and we use just the spread operator to say that we're going to ignore everything else. Right. But right here in this destructured transaction, we could pull in a lot of other things. Okay. But that's not why I'm showing you this. It's just worth a review. And I really recommend that people read this a few times, right? As you start to build, it gets really exciting to think about how all these different transaction fields might be used. But the other thing I just scrolled past on this page, I'll drop this link in the chat as well, is this list of script purposes. And the one we're talking about is spend. Okay. But there are these other ones: mint, withdraw, publish, vote. We got the new governance stuff. It's amazing, right? But once again, our validator only covers this one, and it won't let you use all those other purposes.
This one has a lowercase s. Sorry.
Yes.
The other
Yeah.
one, if you go back to the website real quick, I was just looking at that list, although I'm copying and pasting over here. When it says spend, like these are all uppercase, but they're lowercase when you create a spend, right?
That's correct. Yeah. So another place to look for this documentation um, is in the main site. You can look at purposes, and you can see, once again, it gives you a list. And this is where it shows you like the lowercase, right? All of these words have a corresponding lowercase
Right.
validator purpose that's used over in that Aiken
Okay, a
context.
purpose. All right, thank you. Yep.
Yep. Emmanuel, what do you think?
Yeah, sorry, I don't know, but my question will be like taking us a really bit back. Yeah, at first I don't know if okay, I started the Pluto's Pioneer program on YouTube, which is basically on Pluto's core. And I've been going into Haskell. Then okay now, and I've been seeing Aiken as a substitute language for like Pluto's core. Then I'm not like saying I just want to ask real quick that is it really compulsory you should get into Haskell and Pluto's core before coming to Aiken language? Aiken is really looking a bit familiar. Yeah. So
Yeah. That's also such an important question. Thanks for asking that. Um, the reason we are using Aiken here is because in this moment, it has become more popular. And a lot of people are reporting that it's easier to get started. And we covered a few of the reasons why it's easier last week. But the reason I feel confident about using Aiken is that all of the important concepts are the same. For example, script purpose, right? Whether you're writing in Aiken or Plutus TX, you have the same purposes available to you. Similarly, datum and redeemer and transaction context are all going to play a really, the same role in Plutus TX. Of course, the syntax is different. And so what I would say is absolutely not. You do not have to learn Plutus TX and Plutus Core before starting with Aiken. If you already know those things, Aiken should feel very familiar. But if you learn Aiken first, that's okay too. And if you ever decide to go deeper on the Haskell side, all of the concepts I'm showing you right now are still going to be valid.
oh yeah, okay, yeah, I get. All right, thanks.
Yeah. So we're gonna do this stuff with Aiken right here. And in the future, right, if you do decide to go deep with Plutus TX, a lot of these ideas will translate. Okay. So let me buy us a few more seconds because I do want to see a failing validator. And I said we've got 11 minutes. Yeah, let me give myself like 3 more. I'm going to change this time one more time. So yeah, that we have like 13 minutes to get to this. I'm going to paste a slightly updated time right here. I'm going to save this. Now, because I want to introduce you to traces, I want to also introduce this new tag on Aiken build, trace level verbose. And what we're about to see is the impact of including this when we start building transactions. But before we even get to that, I want you to see how just including this line right here actually changes the UPLC. It changes the compiled code. How do I know that? Well, there's one way that we can demonstrate it. In this directory, I've already built this before, and there's this Plutus JSON file. I'm just going to remove it so that we're starting new again. And you can see that I'm building this for the first time. Then I'm going to run Aiken build, just like we did last week. And I'm going to run Aiken blueprint address in the same way as well. Now, this is not going to work right away because we have both the spending and the else endpoint. The else endpoint is irrelevant to us because we already know that it always fails. But the spending one is the one that we really want to use. So in order to generate an address, I have to specify that. -v for validator. And which validator? This one. Let's try it. This generates a certain address. And remember, if I change this POSIX time by even 1 millisecond, and I build again, and then I build an address again, you'll see it's a completely different address. Every detail in the validator matters, but it's more than just that. Let's go back to the one I was using a second ago, ending in 0. Let's build again. Let's create the address again. And now we're back to where we started, this guy. All well and good. But now I'm going to do one more thing. This tag, trace level verbose, actually gives me a different version of my validator script. It can build trace level verbose. It builds the same way. But then when I try to generate an address, see how it's actually different. The logic hasn't changed, but the way we built it right here, some trace errors are now going to be included. I'm going to leave it to you for practice to see what happens with this validator if you don't include the trace level part. For now, I'm going to show you what happens when we do include this part. Steve, what do you think?
So again, pardon me for asking naive questions. Like you run that twice and and you got the same address twice because you did what you did. And is that address, is that not real until the whole thing runs?
Well,
Well,
this is,
I kind of come from like, shouldn't it be generating a unique address? But if it's not actually live, it's not unique yet. Is that
well,
kind of why?
the generated address is unique every time, right? Like the only way to generate this address is by building the validator that I just built. But this address doesn't really have any purpose on chain until a UTXO is locked at it.
Okay.
Right. And remember this part. This is where it gets interesting. The Cardano blockchain does not have a record of all the addresses that might ever be, right? The only place that addresses are indicated in the first place is in the UTXOs that they're stored at. And when you recognize that, you start to recognize, well, an address really isn't an empty container. That's kind of the wrong metaphor. It's like it's an unlocking code, right? It's just referencing what would it take to spend UTXOs from this address.
Right. So it's kind of like, it's actually the inverse of that, right? It's the UTXOs that is the thing.
That's all there is on chain, right? The blockchain has blocks. Blocks have a set of transactions, and every transaction has a set of input and output UTXOs.
Right. Thanks.
It's really fun to really kind of see how that works. All right, I think we still have enough time. I want to show you this transaction failing in a couple of different ways, but I got to move quickly. So now we already built an address. I also want to save this as a Plutus script. So I'm going to call this SLT2054-demo.Plutus. The file really doesn't, the name doesn't really matter at all. That's just a helpful identifier. I'm going to echo this command into that file, and I'm not generating the address this time. What I want is the Plutus script. So I use Aiken blueprint convert. And now I have a new file, SLT2054-demo.Plutus. I'm just going to use the convenient UI of VS Code to find that file. You can see this is what we expect it to look like. It's a Plutus v3 script. Description is arbitrary, and we've got our CBOR hex. There it is. Let's copy this file and place the copy inside of our transactions directory. Introduce traces. Then on the command line, I'm going to navigate to that example, right? So we got module 205. SLT2054 introduce traces is where we want to be. But before I can use this validator on chain, I need to create a reference script. Some people call this deploying the validator, right? Making it available on chain. Remember that we have this script provided, deploy reference script. It looks like this, and it takes the two arguments, the path to our validator, and the minimum Lovelace required. And when it's successful, it prints the transaction hash that we're going to be able to use in just a minute. So let's run that. Deploy reference script. Our validator is the one we just placed in this folder. Remember, it was called SLT2054 demo. And we don't yet know, this is the cheat I showed you last week. We don't know what the min UTXO is going to be. So let's just type a 0 and see what error it gives us. It says it requires almost 3 ADA. Perfect. Let's change that 0 into this value right here. And now the transaction will succeed. This transaction hash, I'm just going to copy it to my clipboard because we're going to use it in a moment. While I'm waiting for that transaction to be confirmed, oh, it already is. Mempool has 0 transactions in it. So we know that ours just passed. Great. Here it was going in. And here's the reference that it's out. Okay, so our reference script is deployed. Let's jump back to VS Code. And now I want to look at not the Aiken code, but the transaction scripts. So we have one for locking and one for unlocking. The locking one, remember, looks very similar to a simple spending transaction. There's no validator interactions here. All we're doing is we're sending a UTXO to our new validator address. And with it, we're locking a number. That number can be anything. But remember that in order to unlock, it's going to have to match. Let's go golden ratio today. Great, 1618. I'm gonna lock some funds here, and then we're gonna talk about how to unlock in just a minute. But just to stay ahead of the clock, let's try this. So 001 unlock tokens, SLT 2054. What are the command line arguments? We need the validator address and the amount of Lovelace we want to lock. That validator address is what we printed right here. Let's use it. Whoops, and I don't need the cat. And let's lock 6.75 ADA there. How's that look? Go. It's successful. We'll once again wait for that to be removed from our mempool. But while that's happening, let's look at the unlocking transaction. In this one, the only command line argument is a slot, which we will specify in just a moment. But our validator address has changed and our reference UTXO is new. So that validator address, okay, that was a successful transaction. That's great. The validator address is right here. And the transaction hash from our deployment transaction is here. All right. Now our unlocking transaction is ready to go, but it's not going to be valid until about 2 minutes from now. We have just enough time to see this thing fail because we are too early. Let's take a look. I only have to specify the slot. And remember, to get that, I can query the tip of preprod, testnet magic 1. Here's our current tip. Great. So let's run 002, and let's specify this as the slot. And let's see what happens. Now, it failed. Why did it fail? Did it fail because I was too early? Or did it fail for a different reason? You can see it right here. This failed because datum was not equal to redeemer. That's really helpful. Steve, see you soon. That's really helpful. Well, that's not the error I wanted. I wanted to get the error that said I was too early to unlock this thing. So let's try to fix that. Redeemer, this unlock transaction has a redeemer.json file right here. And you can see I'm just referencing this file in the same directory. What's inside of that? That has the int 2024. But that's not the value that I put right here in my locking transaction. I got to make sure those match. Let's try 1618 instead. Now that I've saved that value, let's run the same unlocking transaction. And as you can see, I get a different error. Now datum and redeemer are equal, so that's returning true, but the other check is this time returning false. Any questions about that? This is a really big deal, and I want you guys to understand how to check that your validators are working. Is this making some sense?
Yeah, this is awesome. Thanks, James. So that the way you are logging stuff out, like script debugging logs, that's because of the traces that you included in the script?
Bingo. Yeah.
Okay. Yeah, that's super helpful. Gotcha.
And it comes, I know, yeah, I didn't know this until very recently about Aiken. I had to go deep to play with it a little bit. And there's two things to pay attention to. One is these question marks right here. And we'll look at this in the docs in just a second. So including the question mark on any Boolean value automatically turns it into a trace. It's that simple. And you can see the format of that trace. I think this is pretty convenient personally. I don't need to write like some custom message. I'm happy just to have this. And then the other thing, like you pointed out, is on the build step, you got to include the trace level verbose.
Nice, thank you. The other question that I is um when you build a script like this, is there any consideration on security when it comes to these scripts? Or is it just like on a case by case basis?
Oh man, well this is where Cardano development gets really fun. Okay, this script that we're looking at on my screen right now is completely insecure because anybody can unlock it. But when you're building for production, obviously you want to set pretty strict rules about precisely who can unlock some funds, right? So
Right.
let's just jump back over, for example, if I go back to the transaction documentation here, where is it? I can, these are two of the transaction fields that in practice you're going to use all the time, right? I can look to see whether or not a specific token was included in the inputs and or the outputs to a transaction. And when I do, I'm basically implementing role-based access control. Anybody who holds a token and is able to use it as an input and an output can run this transaction. Anybody who doesn't hold that token, they can't. And then the list goes on, right? We can say that it only works for a specific set of pub key hashes, et cetera, et cetera.
Gotcha. Thanks.
Emmanuel, what do you think?
Yeah, where it was where you had the error of the redeemer not equaling to the datum. I'm asking if it's always the redeemer is always equal to the datum in every cases, or there might be some case whereby you want your redeemer to be different from the datum you are putting for the validator script.
Absolutely, right? So this validator says that they have to be equal, but I could change this bit right here to whatever logic I want, right? You could even build a validator where the datum you had to do some math, right? Whatever the datum is, you got to multiply it by 2 to get the redeemer, right? You can just play around with that. Now, when it comes to actually being useful in your business logic, that's up to you to decide how to use these things. But this is just a really introductory case that shows you how it might work. Now, there's something else I want you to see about datum, right? Remember that redeemer is specified in the spending transaction. Every time I build a transaction to unlock funds from a validator, I have to specify a redeemer, okay? One way to think about the redeemer is as a statement of intent, right? The person building this transaction, what do they intend to do? They can express that in the redeemer. In this case, it's just stating an integer. Hey, I want to unlock funds from this validator, and here's the secret number. But it's checking against datum, and datum is not specified in this transaction. Where was datum specified? Oh, that was specified when we locked the funds in the first place. And because of this bit right here, let's take a look. Let's just query this address for just a second. Cardano CLI, query UTXOs at preprod testnet magic 1. And for this given address, where's that address? This one. Okay. And when you look at the UTXO, remember, I built this UTXO a minute ago. I locked 6.75 ADA, but you also see one more thing right here. It's all in the UTXO directly on the blockchain. There's a number attached to this UTXO. And what number is it? It's the one I specified in my locking transaction. So datum is stored and locked at the validator address. Redeemer is specified at the time somebody tries to unlock this transaction. And that's why we have those two different things, right? What's the data going on chain? The datum. What is the statement of intent for this unlocking transaction? That's the redeemer, right here.
Okay. Okay, yeah. Thank you. I really get that. Thank you.
Awesome. Little by little, right? And I'm going to give you 6 more chances to practice this. Okay, so we now have our redeemer and our datum matching, and now enough time has passed. So shouldn't I be able to unlock these tokens now because the time of my validator has passed? No, of course I can't. Why not? Because I'm still using an old time for this transaction, even though the current slot on the blockchain is now going to allow me to build a valid transaction. I also have to specify that when I build the transaction, and I wasn't doing that yet. So let's try it again. Unlock tokens, but with a more recent slot that's after the deadline. And sure enough, this transaction is successful. You have all the source code for this example right here. All right, the validator is in the Aiken examples repo. The locking and unlocking transactions are in the transaction examples repo. And I'll leave it to you to play around with this, right? Build your own version of this validator with your own lock until time right here. You'll see that it generates a different address, and then you can try these steps for yourselves. 1, deploy the reference script. 2, lock some funds. 3, unlock those funds. And if you really want to explore, try to make sure that you can see all these errors happening. That's enough for us to now keep going. What we're going to do is continue building on this example by adding one feature at a time. You've now seen how to specify the spending purpose. I introduced you to how traces work so that you can see specific errors in your code. And by the way, let's back up for 1 second. The version of this script that I deployed and showed you right here that actually can show you these script debugging logs, you would not use this in production. Here's
Thank you.
why.
Yeah, that
Right.
was my other question.
Right.
Thanks.
Yeah, you would have tested the script already. And then once it's tested and you know that it validates exactly when you want it to, and it fails to validate exactly in all the other cases, right? Then you would go back to Aiken build and you would say just Aiken build. And when you do this, you would get a different address. Once again, let's look at that address. All right, now it's not this address anymore. This is the one where we have the errors baked in. This is a productionized version where those errors are not actually written to the CBOR code. And that's a good thing because the longer our CBOR code, the more expensive it's going to be to use it on chain. So yeah, I just wanted to make sure that note is made. And that's something we can say that again and again, right? But I want you to know how to express those traces, but in production, get to this address. Now, the simple fact is, even running trace level verbose and using this address the way I just showed you to right here, even this is unnecessary because we have robust testing built directly into Aiken PBL. So Caesar, you already discovered the vodka and some of the mocktail functions, right? That is what we're going to cover deeply in the Aiken PBL course. So once you get to Aiken PBL, we won't even be building transactions on any live network. In that course, we're only going to show you how to test your validators with mock transactions. Any questions about that? And when you use mock transactions, these trace errors will show up seamlessly. It's wonderful. All right, but we're going to keep doing things the slow and hard way because this is your chance to get hands-on in the sandbox, see these details one at a time directly on pre-prod. Let's move to the next example. We are finally ready to take a close look at datum. I just introduced to you the essentials of how you include it in a spending validator, but the truth is testing that datum equals redeemer is not that useful, right? You might find advanced cases where you want those to be equal, but the truth is your validators are probably going to perform a little bit more logic than that. So let's start using datum for something useful now. In this example, we're once again ignoring redeemer. We just put this underscore back on it so we don't have to use it. This time we are going to use datum, however, and we're going to use it for a different purpose. As you've seen, in the first few examples, we are hard coding some lock until value. And that's cute for testing purposes and to learn about this for the first time. But the truth is, this is really not useful, right? The moment this deadline passes, this validator basically turns into an always succeeds validator and doesn't really do me any good anymore. What I'd rather have is a more flexible validator that doesn't force me to specify a single deadline for all UTXOs that might ever pass through. Instead, it would be better to specify this time for every individual UTXO. And then I can reuse the same validator over and over again, just with different deadlines every time a UTXO is locked. And this is the code for doing that. Look at the difference. We're still keeping the validity range from the transaction. Nothing has changed about our spending, signature, how we grab the transaction, destructure it, and pull that validity range into the must start after function. No changes there. But right here, we handle datum. Now, datum is an optional integer. And when we define something as optional, a few other keywords will come into play. In this case, the keyword we're going to look at is sum, okay? So when you have something that's optional, and maybe some of you have studied Haskell, so you're familiar with the concept of maybe, just, and nothing, okay? But the idea here is, hey, you say I might have something. Well, what are the two options? You either do or you don't, right? So if I say I have maybe an integer in Haskell, I would have just an integer or nothing. In Aiken, I say I optionally have an integer, and I either have some integer or nothing. I'm leaving out a few details here, but I'm trying to paint kind of the big level picture, and you're going to get to see more and more about how this works. But for now, if I say I have some int, this datum int is the int type right here. Okay, so if I have datum opt, which is something and an integer, now I can operate on that integer directly. And where am I using it? Oh, I'm passing it as the lock expiration time. I used to specify that value by hard coding it and pass it here. Now I'm pulling it from the datum, passing it to the same function, and this allows me to store a different unlocking time with every UTXO. How do you feel about that?
So are they going to supply, and when it says int, I assume it's big enough to handle the longs that they were giving them. Is that
That's right, yeah. So it can handle a POSIX time, that's right. And we're going to supply it in the locking transaction, just like a minute ago, we supplied a value as an arbitrary integer that the redeemer had to match.
and eventually like all of these inputs, they're going to be done with forms or some sort of API call to get that the current
Exactly.
time or something like that.
Exactly. I'm showing you shell scripts so you can play with these things, but obviously for the end user, they're going to want to build transactions in a web interface. That, by the way, that's what Mesh provides, for example. Okay, so we have the Mesh PBL course as well, where you can look through how to build the front end that allows you to pull in validators like this one. Now, there's something really crucial right here that's pretty awesome. And this did not exist before Plutus v3. In Plutus v1 and Plutus v2, if you built a validator and you wanted to lock UTXOs at the address, you had to include datum. And that's why actually some of this code would have been simpler in an earlier era. In Plutus v2, for example, it would be acceptable to just say our datum is an int and then use that datum directly right here. That's no longer the case. And the reason that's no longer the case is actually a really nice upgrade to how validation works. Now it's possible to lock a UTXO at a validator address without including datum. And that's what this case catches right here. Basically, we're saying if there is some datum, then validate on it. But if there's not datum, right, when datum opt is anything else besides some datum int, just let anybody spend it. And that's a really nice feature. What that means is if I accidentally locked a UTXO at this validator address and I forgot to put an expiration time on it, I would still be able to retrieve it because of this condition right here. Once again, all other purposes will fail. Any questions about this introduced datum spending validator?
I think one of the confusing parts to me was that like the datum int only gets introduced when when you're like creating the script, right? Providing that information. But validity range isn't even a thing until somebody decides to spend this, right? So it's like you're not
Very
really getting
nice.
all the arguments, kind of like you would like in JS, where you need to sometimes if you're not currying, you provide all the arguments and the script is executed. This is like you're building a partial state until it fully completes.
That's nice. Yeah, that's really good. And this is that's a really good overview. Let's try to draw pictures of that because that's the mental model we need people to understand, right? Like the datum is set whenever we lock it in a UTXO, right? This is in some, like you said, like some stored state, right? But to unlock a UTXO that includes that stored state, that requires some future transaction. And that validity range is coming from that transaction that'll happen sometime in the future. Well, let's see how that works. So once
And
again, we have
in
example.
general,
Oh, yeah.
sorry. I was just going to say, in general, in the future, that datum option is going to be some sort of struct that we put together with a bunch of different
Yes,
stuff in it.
exactly. Exactly. Validators become really powerful, and any meaningful business logic is going to come from you defining your own custom datum types. And those datum types, like you said, it can be a struct or a record, right? With many different fields. They can even be nested fields. And then you can imagine what happens when you store complex data on chain. And now you have the ability to run all sorts of validation logic against it.
And the redeemer is generally is a JSON file that you build. Okay, sorry, just
This is great. The datum and redeemer can be, and we don't see the example here. If we have time, let's go and look at an example. But in the validation code, datum and redeemer are both defined by the same format, right? It's just a struct. Then when you use them in a transaction, with Cardano CLI, for example, we have that convenient JSON structure, and we're going to look at that right now. Okay, so let's try to use this thing. We're going to repeat the steps, and hopefully this is starting to feel like muscle memory, that you know what those steps are. We're going to take our validator. Let's go out of this directory and into number 5. I'm looking for the akin.toml file. I see it. When I run akin check, we're fine. I'm not going to take the trace errors this time. There's only this one, right? Valid expiration time. So if this thing fails, I know that's why. So I'm just going to build this in the most efficient way. I'm going to generate an address, akin blueprint address. I know that this command is going to fail, but for convenience, I like to just copy and paste what it tells me I can use in the error here instead of trying to remember it. So I'll just highlight this bit and paste that as the validator I want. So here's the address we're going to be using. And let's also create a script. We'll call this one SLT 2055-demo.plutus. It's an arbitrary name, as always. I'm just trying to make it helpful. I'm just using the bash command echo and then the little arrow to take the results of this call inside the parentheses and save it in this file name. But it's not the address I want. I want the converted script. So there we go. Now I can see that I have that SLT 2055 demo. I'm just going to grab it and copy it right here and paste it into my transactions directory. So where's paste? Paste. It's right in front of me, right? Why not? There it is. And let's get rid of these earlier tests. The JSON, and I'm going to get rid of some, that's okay. Clean up some of these extra transactions that we've built. That looks good. So now here, let's navigate to the 2055 transactions directory. And what do I see? I see a locking transaction, a claiming transaction, a redeemer, and the Plutus file that I just created. I want to deploy this thing on chain. So let's exit this directory where I have the deploy reference script example. Let's run that script with our brand new SLT 205 demo. I don't know the min UTXO for this thing, so I set 0. It's given to me right here. And already notice, I don't know if you remember what our min UTXO was before, but it was closer to 3 ADA. It was like 2.8 or 2.9 something because I was including those traces. I'm saving almost an ADA right here by not including the traces. That's pretty nice. So let's run this again. Let's pull in that amount and we're submitting it to chain. I get a transaction hash and I'm going to want that. So I copy it to my clipboard. I move into the claim UTXO, which is where I'll need to reference that UTXO, that reference script. And I replace that. Let's fix the addresses while we're here. In this example, oh, good. And I'm showing you a few more things here. We'll get to that in just a second. But let's grab the address right here and hard code that in here. Okay, so actually our claiming script is going to be ready to go. That's very nice. But before I can use it, I need to lock some UTXOs. And this script is a little bit more complicated. And we're doing things a slightly different way just to show you how this works. All right, remember that previously we've been generating the address with Aiken, and then we've been applying it directly in our script. This time you're being asked for a validator path as a command line argument. That validator path is being pulled into a Cardano CLI command that automatically generates the address for us. But just to confirm that this works, let's give this a try. I'm just going to copy this, copy this line right here and pull it in right here. And the validator path, I'm already in the right directory, SLT 2055 demo, right? So let's just pass it that Plutus file and build an address for pre-prod right here. What do we get? Well, that's ugly. Let's, just to get the carriage return, let's wrap that in parentheses and echo it like this. That's better. Now, notice that this address ending in GQG6SW6S matches the one that Aiken produced right up here. Where is it? Right here. Same screen. I'm looking around for it, right? So whether you ask Aiken Blueprint to derive the address from your script, or you use Cardano CLI, you can see the result is the same. That's a really good thing. Okay, so either way, we can get the address, and that's why I'm showing you that you can pass the validator path if you want to. We're still going to identify the amount of Lovelace we want to lock. And then, because this is a different kind of validator that allows us to specify the unlocking time each time, I'm just going to pass it some number of minutes that I want to elapse. And then I'm going to use bash to take those minutes and calculate some unlocking time. Check it out. I can use the date command and just multiply it by 1,000 to get the current POSIX time, the milliseconds. I can then convert minutes into milliseconds, just multiply by 60 and by 1,000. And then I can figure out when I want the funds to be unlocked by just adding the current POSIX calculated here to the duration calculated here. And then I'm going to take that end time, and that's going to be my datum value. There it is, right? So now attached to each UTXO will be a specific unlocking time. Any questions about this? I have a fourth argument that just allows me to pin some reference name on all of the outputs here, so I can distinguish between them if I wanted to. and that's a little convenience. So let's do this. Let's lock. 2055. Here's my lock intro, or excuse me, lock UTXO. We can look at that right here for reference. These are the 4 arguments that I was just looking at. And let's say, okay, 0, 0, 1. It takes a validator path. I already know that because it's right here. The amount of Lovelace to lock, some small amount. How about 4.9 ADA? Okay. Duration, let's just lock this for 4 minutes. And we'll call it example 1. It does the math for me. Duration is 240,000 milliseconds or 4 minutes. We have the current time, we have the end time. And now when I Cardano CLI query the UTXOs, testnet magic 1 at the address, this address right here. It already confirmed on chain, and you'll see that the datum number is this timestamp, which is exactly what was printed to the terminal right here. All right, so here's an example of a UTXO that can be unlocked a little bit less than 4 minutes from now. Any questions about that?
When you're saying unlocked 4 minutes from now, that means you can run this transaction in 4 minutes, or you have 4 minutes to complete it.
Great question. Okay, so in our logic here, we want the integer, right? This datum int is the time that the lock expires, right? So it's locked until. So in this case, it means that we won't be able to build the transaction until 4 minutes from now. But you could just turn this sign around right here, turn it into a greater than sign, and then you would have the other case that you just described. Let's
Hey,
watch this transaction fail. Go ahead.
hey, real quick on that last screen, where we're the validator on line 29, where it's like it'll go through if no datum is present. Would you do that in production, or is this just like on an oopsies, you know?
Oh man, I honestly don't know. I think this is going to be useful, but it's so new that we haven't fully played with it yet,
Okay.
right? But I can speak to a use case, right? So on the Andamio team, we built a validator that holds a treasury of funds for any group of people working together. And in Plutus V2, where we developed that validator, we had to make sure that there was trivial datum attached to every funding UTXO. And that datum, it's the simplest kind of constructor. It's constructor 0 with an empty set of fields, but we still were required to include that. Now, with this tool in our hands, first of all, we don't have to do that anymore. And second of all, we now, out of the box, have the ability to take donations to a treasury. Anybody can just send Lovelace to a treasury address, and then the organization would be able to unlock it. Now, this is not quite the logic for that, right? This acknowledges that it's possible to unlock a UTXO that has no datum, but I wouldn't leave the word true here like this. I would still want to set some rules for who can unlock those unmarked UTXOs.
Okay, right. I guess that was my question because
Yeah.
wouldn't it bypass line 21 where it's actually checking And the whole point of the
It
script.
would. In this case, it does, right?
Yeah.
And so here, right, but here, this is just the trivial logic. And as long as you replace this logic, sky's the limit.
Thank you. Okay.
All right, should we try to unlock this thing? I think 4 minutes have probably passed, but I know some tricks. So first of all, let's just look at that unlocking transaction. We already set it up. We put the validator address, the reference UTXO. We just have these helper scripts, which by the way, that's why we're importing utils up here. And if you want to see how sender TXIN is derived from get address biggest Lovelace, right? Or same thing for the validator, you can take a look at the util script that's provided. So all it's doing is it's running Cardano CLI query UTXO for some address, and then it's using some bash magic to just get the transaction hash that we want. All right. So we're going to claim this thing. It looks like all we're going to have to do is specify the starting slot that's going to be converted the way we want it to, and provided here, invalid before. Now, also, this is showing an example where an end slot also matters, but it's irrelevant to our validator. I'm including this here as an example of how you can build a transaction in one moment and sign it and submit it later. Anytime that an application, for example, is building a transaction for someone else to sign, which is all of DeFi, for example, right? The DeFi application builds the transaction and then it sends it over to your wallet, probably a browser wallet connected, right? To sign it. It's a good idea to include a validity range on a transaction, even if there's no validator involved. Why is it a good idea? Well, you wouldn't want to be able to build a transaction today and then 3 days from now, when market conditions have changed, be able to submit it. Does that make sense? If people were able to do that, they'd be building transactions all the time, but then holding on to them to maybe submit them to the chain when it's more convenient. And this is a nice way to protect against that. It's common to include a pretty short validity range. So in this case, we're saying just 20 minutes, right? 20 times 60. Even that might be long. Mix, what's your preferred amount of time for a validity range to last?
Depend on some, if you want to be really fast and confirm 5 block of Cardano for the sake of, being sure that there is no any rejection, drawback, or anything, it would be around 5 minutes.
Yeah.
So 5 minutes, 5 block, and I mean mostly, and that would be enough. But the thing is, if you do 5 minutes, the amount of time it takes for the user to sign that transaction and the amount of time of that transaction leave in mempool must be within that 5 minutes. So if your user has really lengthy password, like, I don't know, 30, I don't know, 60 character to write or try to find that, and the network is, congested, busy, that 5 minute needs to be much more longer, like maybe even 15 minutes. But 5 minutes would be really the minimum, I think.
And it's crazy, right? Because like you just described, there's technical reasons why 5 minutes might not even be enough. But on the other hand, in a fast-moving financial market, 5 minutes can be a big difference in your outcomes.
Yeah, yeah. That's why there are actually tools in some DEXs, like DEX Hunter, that they do the transaction chaining without submission. So the whole thing is happening outside of blockchain. I mean, the mainnet, or even Hydra can maybe solve that. Do your stuff on the side chain or product chain and then submit it on mainnet. Why? Because things can be faster. And again, it would take 20 seconds. I mean, average 20 second for Cardano to produce one block. You can reduce it to 5 seconds or 1 second even.
Right. So suffice it to say, right, everything we're doing in these lessons is enough to give everybody a first step. And I hope you're getting a good picture of how validators and transactions work. But obviously, building for production, we go way, way beyond this. And the fun's not going to stop, right? So we're getting started now, but let's keep going deeper and deeper into these real problems. Let's try to unlock these tokens for now, right? And this is not going to fail because it's definitely been more than 4 minutes, but I can show you how to build a failing transaction anyway. Let's take a look. So first of all, I know that I have the script right here in this directory. I know that all I have to do is specify a starting slot. Wonderful. But if I query the tip again, let's run this script, but let's take 10,000 seconds off of it, right? If I do that, now my starting time for this transaction is much earlier. And of course, it fails on the validation side. Now, we're not shown explicitly that error in our transaction log now, right? We're just we see that it failed, but script debugging logs are blank, and that's because we didn't include the trace verbose. All right. Now, of course, if I try to run the same transaction again, but this time I use this number, it's going to pass. And what I'm not showing you right now, but you can try to play with on your own, is try this challenge. Try to lock a UTXO at the address with some datum in it, and try to build a transaction that actually passes this validation step, but because the validity range is invalid for the transaction as a whole, it fails anyway. If you don't understand what I mean, don't worry about it. But if that makes sense to you, if you can build a valid transaction that's still unsubmittable, that's a really good way to get a feel for the different roles that the protocol layer play in validating just the transaction range, and the validator level plays by giving us kind of that unlocking deadline. So I see Faizan's comment. Yeah, let's take a look at this right here to close out for today. Now, I want to compare lines 17 and 18 to this block right here. Remember, once again, this is an unlocking transaction, right? It's a little bit misleading to call it an unlocking transaction because technically every transaction is an unlocking transaction. If I send 5 ADA to Mix, I have to unlock UTXOs from my wallet so that I can spend them and send them over to him. And that's all that's happening right here. TX in, just any given TX in. How do I unlock this? I unlock it by signing for it. The only reason I have to sign this transaction is to unlock this guy right here. We're talking about unlocking transactions, though, in a more specific way. We're talking about them as unlocking from a validator address. And you could decide if you like the word unlock. I like the word claim as well, so that's what I named this script. But this is where the validator unlocking happens, and it's not sufficient just to specify a TX in. If all I want to do is spend, that's fine. But if I want to spend from a validator, there's more I got to do. So what do I do? Well, first of all, I have to specify the validator that's going to be invoked. And the way I do that is by supplying the reference UTXO. Why? Why is that enough? I'm going to copy this transaction ID right here and head over to Cardano scan. Reprod.Cardano scan. And we are looking for the UTXO at index 0. 0. That just means it's the first one in the list. So let's look at the outputs of this transaction, and let's look at, yeah, the first one here. Okay. Oh, is it not showing it to us? This transaction. Oh, Cardano scan is not showing me the little script button now. It's not there anymore. Okay, so instead, let's do it this way. This UTXO. That's all right. Let's just query the address. This is my example reference script address, so I'm going to query this for you. And I know we're at time. We've been going for 90 minutes. I'm going to go for like 5 more minutes just to close the loop on this bit right here, and then we'll close out. So I want to query this address where I'm storing all of these reference UTXOs. Cardano CLI, query the UTXOs on preprod at this address. Oh, not that address. At the address that I just pasted from Cardano scan. And this has a whole bunch of UTXOs in it. You can see they're all similar size, somewhere between 1.5 and 5 ADA, okay, for different sizes of scripts. But nothing that I'm seeing right here shows me that there are that these would have reference scripts attached to them. The way I can view those other details is by adding this out file tag to Cardano CLI query UTXO. Out file, let's just call this ref. It doesn't matter what I call it. And let's just save it as a JSON file, refscripts.json. Fine. It doesn't print anything to the screen. Instead, it saves that file. And I can open that file and I can see something very special. Each of the UTXOs has a reference script. And there they are. This looks familiar, doesn't it? Ooh, there's an old one from Plutus v2 hanging around. There's other ones from Plutus v3. Those are the ones that are more recent. And you can scroll through these. And this is why I can simply specify a UTXO right here and pass it as my spending TX in reference. Let's find it. E1, E1. These are alphabetical. So 1, 2, 4, 5, 5, A, C, D, more D, E1, E1. There it is. This is the reference script that I just deployed like 10 minutes ago. And this right here is the on-chain representation, the CBOR string of this code right here. And so this beautiful thing, all I need is this transaction, this UTXO, transaction hash 0. And now I have access to this compiled code. And all of you do as well. I'll drop this in the chat. You're free to use this validator as long as you know the address that goes with it. Oh, that's the address. Copy. There you go. Okay, so that answers just one part of our question. You can see that when we are unlocking, we have to specify where the validation logic is. That does that. Then we specify what type of script it is. A common error right now, because we just transitioned from V2 to V3, is if you're copying and pasting documentation that's a few months old, I might have a V2 right here. And if I tried to run this script like this, I would get an error that's a little bit confusing. It talks about the validation error of the chain. I said error. So we have to specify that so it knows what version of Plutus is being used in this reference script. Then we say, well, our UTXO, we don't care what it is because it's already on chain. The inline datum is present. And you could see that when we looked at this on Cardano CLI a few minutes ago, the POSIX time that represented the unlocking moment was right there for us to see. Now, that's not the only way to represent datum. If you want to keep it more opaque, on the public blockchain, you can hash a complicated object and include it instead as a datum hash. And let's look at that for just 1 second as well. Oh. Cardano CLI transaction build gives us the documentation. TX in datum. It can be a file, a CBOR file, a value, or we can say that inline datum is present, right? So we have a few different ways to think about that. I'm not going to cover all of those right now, but I want you to know these documentation are here. And more importantly, when we first placed the datum on chain in our locking transaction, we used TX out inline datum value, and that way we were able to just include a number. TX out inline datum value, right? So that's the one we used. But where is here, right? Another option for including datum is just to include a hash of some data. And notice you can still supply the data as a JSON file. That's convenient, right? But it doesn't place all of that raw readable data on chain. It simply hashes it. And we can get into why that's useful as we start to look at some deeper examples. So that's the inline datum part. And then finally, we specify a redeemer to go with it. Okay, and we're not using it for anything here. This redeemer file is just kind of it's similar to before, but it's not actually doing anything. And in the very next lesson, we're going to actually use redeemer for the first time. That next lesson is 205.6. And that's where we can pick up, same time next week. Any questions before we close out?
Yeah, the inline datum, you can turn it into a hash. I assume you can turn it into something that'll turn it back into JSON on the other side.
Great question. Okay, that's a critical question. The answer is no. Okay, hashing is one directional. Okay, so if I have a complex datum object with all sorts of information that I want to maybe keep opaque to the end user, I can in my application create a JSON object, and then I can hash it, and I can put that hash as a datum hash. And then when I want to unlock that file, it's actually going to be a different command here, but essentially the idea is I need to be able to recreate that hash. And so one way to think about this is it validates that you have access to the off-chain store of the same information.
Right. So you're not going to be able to take information, condense it down, but you can store it somewhere as long as it'd be more encoding than hashing, I guess is what you'd say then.
It is more of an encoding, yes. And it can be brute forced, right? If it's a simple enough and valuable enough. Early on Cardano, Andrew Westberg did a demo of how long it would take to brute force figure out some valuable datum hash. And he showed that, you wouldn't want to just put a secret number on chain with a million ADA attached to it because somebody would be able to figure out what number maps to that hash. Faizan, we can't remove the Redeemer line, which maybe that'll change in the future. I'm not sure. But you recognize that we're not using the Redeemer in our validator right here. So it will be nice to be able to leave it out. But anytime you want to unlock from a validator address, you have to specify a Redeemer in one way or another. All right. So the text to accompany all of these lessons is now live at Andamio, starting right here. And the first 4 lessons are live, 2051 through 2054, which we just covered earlier in today's session. 2054 is almost done. I have to update the links at the bottom because I just copied and pasted this from the previous one. But the idea is that you'll move pretty slowly through lesson 2051 and 2052. This lesson is the long one because it's introducing all of the processes that I was showing you a few times in this lesson, from deploying to locking to unlocking. But once you understand those steps, deploy your reference script, lock a UTXO, and unlock it, you'll be able to move pretty fast through the rest of these lessons. We covered this one last week. We covered the introduction to traces earlier today, and you can see it's not a very long lesson. In this video, we just looked at datum, and oh, that lesson's not live yet, right? So we just covered 2055. I'll have that text updated by the end of the day today. And then 2056 and 2057, we're going to cover these next week, looking at a specific use case for Redeemer and how to apply parameters to build even more flexible sets of contracts. Oh, Harsha, I don't know if I heard you.
No, that was supposed to be a private message. I forgot and sent it to him.
Cool. Cool. Any other questions? All right. If you're watching this, you made it all the way to the end on YouTube. Congratulations. Be in touch. We meet on at 14:30 every Wednesday. And we'll be continuing to go for most of the rest of this year. There'll be a couple of breaks for holidays, but I think we have 6 or 8 live coding sessions left. So we're excited to keep it going.